Hello and welcome to this instructional video on the DGUV calculator, which is among a suite of 10 tools that are designed to allow a competent electrical engineer to undertake arc flash hazard calculations. My name's Mike Frayne and I'm the creator of the European Arc Guide and also the author of the book The European Arc Flash Guide. The calculator is based on the German DGUV guide to the selection of personal protective equipment for electrical work. It's derived from what is colloquially called the box test, IEC standard 61482-1-2, and further information is available in detail in the European Arc Flash Guide. The calculator can be used wherever there's a requirement to provide PPE that has been tested to the box test standard. To access the calculator, select the Calculators tab and then DGUV Box Test. If you select Expand or Collapse, you'll be able to provide preset configurations which will reduce the need for repeated data entry wherever the same conditions are being used in several calculations. The second option is to click on the DGUV box test instructions, and this will give you access to comprehensive guidance on how to use the calculator. The first field is voltage, and this is where you can enter the three-phase line-to-line volts, and in our case this will be 400 volts. Next is a maximum and minimum short circuit current in kA. A maximum and minimum short circuit current is required in accordance with the German standard VDE 0102 and deals with short circuit currents in three-phase AC systems. The maximum minimum short circuit currents using IEC 60909 voltage correction factors are given in this guide in the prospective short circuit current calculator. In our case, we've determined this to be 15.5 and 13.7 kA respectively. Next we have the conductor gap distance, which may be the distance between the bus bars, equipment, terminals or cable conductors, so the figure that we'll use in this case is 60 millimeters. In the next field we have the working distance, which can vary with tasks to be performed, but in our case the figure is going to be 300 millimeters. In the next field, an R over X ratio is required, which is not always easy to establish. However, the R over X value can be found from the prospective short circuit current calculator as a reciprocal of the X over R value for low voltage circuits fed by a transformer. In this case, we've determined the R over X value to be 0.3. In the next field we have the current limiting factor, which is a factor that is simply applied to the minimum short circuit current given previously to produce an arcing current. For low voltage applications like this, the DGUV guide states that a safe figure to use is 0.5, which means that the arcing current is simply 50% of the minimum prospective short circuit current given previously. For higher voltages, the DGUV guide recommends a kB factor of 1, meaning that the arcing current is equal to the minimum prospective fault current value. The transmission factor field represents conductor geometry and is derived from whether the arc is enclosed in a box, or semi-enclosed, or in air, but against the rear wall or in open air. The diagram shows three configurations, and the first one is a box where the arc propagates directionally towards the worker. In this case, the transmission factor, kT, is 1. The next diagram shows a rear wall only, and the range of transmission factors is between 1.5 and 1.9. And the last image shows an open air configuration where the arc will propagate in all directions and the factor is 2.4. In our example, we'll use a figure of 1.5. We can now press the submit button, and as can be seen, an arcing current of 6.85 is displayed, which is simply a product of current limiting factor and minimum short circuit current given previously. You can use this figure to determine the disconnection time from the time current curve for the upstream protective device. We've determined this to be 0.1 second, and we can enter this into the disconnection time field here. If we press the submit button again, we can see that the PPE that is required will be Arc Protection Class 2, APC2, in accordance with IEC 61482-1-2 box test. This is the highest of the two arc protection classes that are possible when in accordance with this standard. The calculator gives the option to use a lower protection class 1, and as can be seen here, by changing distance or disconnection times. So the rather precise figures shown are the exact parameters that will be required to lower the APC level, and if we choose 0.065 for the disconnection time, we can see that this will indeed lower the protection level to APC1. Similarly, if we substitute the working distance for the suggested value, this will also return APC1. If you go to chapter 14 of the guidebook, there's an in-depth explanation of the calculations and the methodology used in the calculators, and there's also lots of information on the standard in chapter 4 prediction, chapter 7 protection, and also in chapter 16 on rules, codes and legislation. I do hope that you enjoy using the calculator in the field on your phone, tablet or PC, and that you find this guide to be a valuable resource to help determine the arc protection classes in accordance with the box test. Thank you for your time.